Yes, members, welcome back to another YouTube channel. This is Shaka Annual Math Motion, your math tutor. I think we are fine. Members, as I promised, that we're going to go ahead with our estimation of trend, and today we're going to talk about the modified exponential trend, gompertz curve, and logistic curve. Yes, members, let me take you through now with ease how we model the modified exponential trend. Members, remember in the past video, the previous video, we saw a linear trend, a quadratic trend, and a simple exponential trend. Now today we're going to talk about the modified exponential trend. Yes, I'm saying today we'll talk about third is going to be the modified exponential trend. And members, you know that by the definition yt equals to, now here I have beta naught plus beta 1 times beta 2 power t times the error term, and then as you see here, we shall now need to find beta naught, beta 1, and beta 2. Now members, here we have now a different approach. This approach is going to be quite interesting, that we shall now need to have these four following rules. Like number one, what we need first to do is, now we just need to first divide our series we are given into 3 equal parts. Like divide, first divide the series into 3 equal parts, i.e. you divide your series into 3 equal parts. I think therefore if you have 15 values, just divide by a fixed order of 5, 5, 5. Have now a division of 5, 5. We say from here up to here is 1 division, from here up to here is 1 division, so from here to here you have 1 division. Now after there, what we need to do next is to find out the sum. To find the sum of each third, and then we name it S1y, S2y, and S3y. I'm saying what we need to do is to find out the sum of each third, and we name it that way. And then lastly, part 3 is now to find the n, and n equals to number of elements in each third. Yes. Now members, now for this example of ours, we just need to find now this example of ours, just need to find S1y, find S2y, and then S3y. I'm saying S1y refers to the sum of the first third, S2y refers to the sum of the second third, and S3y is the sum of the last third. Members, from here, if you have if you add 17 plus 8 plus, we shall have our answer as 169. Then if you add 58 plus 55 plus 57 plus 58 plus 68, we shall have our answer as 296. Yes. And then lastly, if you add this last part, we shall have our answer as 340. Now members, as you know that if you're finding this exponential trend, you just need to find now the coefficients beta naught, beta 1, and beta 2. Now here, shall use these formulas to estimate our coefficients. Now shall begin with this formula that beta, the first way beta 2 power n is going to be the same as having S3y minus S2y over S2y minus S1y. Just like that. With that, we shall be able to find our beta naught with ease, our beta 2 with ease. Likewise, in order for us to find our beta 1, shall say beta 1 equals to now, shall say it's the same as having S2y minus S1y, like this, into beta 2 minus beta 1 over beta 2 power n minus 1, everything squared here, and then we shall be able to get our beta 1. And lastly, to get our beta 1, shall be able to just find it in this way. Shall just need to have 1 out of n, shall need to have 1 out of n, like this, into S1y. Remember S1y is the sum of the first quarter of the first third, minus, now again here we shall have now beta 2n minus 1 over beta 2 minus 1 times beta 1, something like this. If we're able to solve these 3 equations, we shall be able to have our coefficients, and then also have our equation. Therefore, members, let us now go ahead and find with ease each beta naught, and then we shall be able to have solved our simplified our modified exponential trend. Now remember, let me put off this half space for this part, and then we go ahead. Now for beta 2, you just need first find beta 2 power n. Now remember, beta 2 power n, this is the same as beta 2. Now our n, remember our n, you said our n is 5, because n is the number of each third. So the number of elements in each third is 5. So shall have beta 2 power 5 equals to, now S3 is going to be this one, 3, 4, 0 minus S2y, which is 296 out of now S2, which is 296 minus 169, something like that. Then if I have the answer here, then it's set power 1 over 5 shall have our beta 2 equaling to, if I have the answer here, now power 1 over 5, I'm saying it's the same thing as having beta 2 equals to the whole of this power 1 over 5. And then our answer beta 2 is going to be, if you calculate properly, you have your answer as 0.809, something like this, with ease. Now we are saying that now to find beta 1, just need to recall the formula that beta 1 equals to, what does it equal to? It equals to S2y minus S1y, something like this, times beta 2 minus 1 over beta 2 power n minus 1, but everything here squared. Now our task now is finding now the answer there. Now if we do substitution, we shall just need to see that by substitution, S2y we shall have 296 minus 169, something like this. Now into beta 2 we have as 0.809 minus 1 out of, now this one is going to be the answer we had here is going to be like, if I have 3, 4, I'm saying that's I'm going to have here, I'm going to be okay, the same answer then but power 5. However, it's going to be this answer then power 5, it's going to be 0.809 power 5 minus 1, but everything here squared. Then if you do properly you have your beta 1 equating to, beta 1 is going to be equal to, if I have my beta 1, basically you need to have something like beta 1 equals to negative 56 point negative 56.808. Members, make sure you have this answer, but here just a matter of knowing the formulas and then knowing the trick that we have to divide the yt into 3 equal parts, and then we have to have the sum of the first three of the sum of each part we had, and then we substitute into our formula. And then members, lastly, we can now have our beta naught from, if I put space here, how my beta naught is going to be of the form now. Beta naught, we said beta naught equals to what? Equals to, we said 1 over n into S1y, yes, minus, now again we have beta 2 power n minus 1 over beta 2 minus 1 times beta 1. Now here's what our beta naught is going to be the same as having 1 out of 5, which our n is 5, into S1y is 169. Now minus, what is beta 2 power n? Remember our n is 5, is going to be this answer here. So it's going to be 0.809 power 5 minus 1 out of 0.809 minus 1. The whole of this multiply it times beta 1. So 1 is negative 56.808. Now remember, if you do proper calculations, you shall have your beta naught as what's the answer you get here as your beta naught? For my answer I had my beta naught as 72.671, and then by that I'm able to now write my modified exponential distribution. Since I have beta naught, I have beta 1, and then I have beta 2. I will just say that now my yt, my mode is going to be yt, so it will be the same as having beta naught, which is 72.671, yes, like that. Now plus beta 1, what's my beta 1? It's going to be this one, negative, I have negative 56.808, and then lastly times, this one times into, my beta 2 is going to be the same as our beta 2 is going to be 0.809, like this, 8 power t, and that is my modified exponential distribution. Remember, I come again, I say that these things is simple. How do it is that we need to first of all divide our cells, our yt into 3 equal parts, and then if we have the 3 equal parts, the next part is having the sum of the sum of each part as S1y and SY2y and then S3. Then also determine the n. The n is the number of the number of elements in each stud, and then it is a 5. Now what we need to know is that to find the coefficients beta 1 and beta 2, you just need to have these formulas in head. Beta 2 power n is the same as having this. You just need to have this formula in head, this one, and then apply to this one for beta 1, and then likewise we must apply for beta 0. And then with that we shall be able to answer our questions with ease. I think members, for this part is also fine. Let us go and see how can we do for the gompertz curve. Remember, as I said, the gompertz curve is an S-shaped curve. It shows that there is a slow growth at the start, then rapid growth, and then also there is a decline at the end, because there is we have limited resources. Now members, I think I explained these curves properly in my previous video. Today I'm measuring on how we can solve these curves, and then we see how they look like. Yes members, now let us now go through how we do the gompertz curve. Yes members, now let us now go through how we find a gompertz curve. Yes, as I say, the gompertz curve also is a one part of how we estimate the trend. And then now for here, what I'm going to do for a gompertz curve now, our fourth part is gompertz curve. For the gompertz curve, what we're going to do here, remember now this equation is that yt equals to now beta naught power beta 1, then power beta 1, then is also power beta 2, then beta 2 is power t. Are you getting the way it is? I'm saying it's the same thing as having like we have our curve is in the form of yt equals to beta naught, but beta naught now is power beta 1, beta 1 is power beta 2, then beta 2 is power t. That's what we call a gompertz curve. Now we also need to now solve for beta naught, beta 1 and beta 2, so that we can able to have the gompertz curve as we know. But now here also we have three. Also here we also have three rows we need to follow. First of all, what we need to do first of all, now we need to find ln of ty of yt. First of all, need to first find the column of ln yt. As I've got here, you see that we had cells. Now we need to find ln of yt. After getting the ln of yt, the second part is now we divide the ln of yt into 3 equal thirds. Like we divide into 3 equal thirds, and then what are we going to have now here? That from here up to here, the first third, then from here up to here, second third, and from here up here, the last third. Now from there, what we need to do again? Now we need to find the sum. Part 3 is finding the sum of the individual yt's. Yes, find the sum of the each part. In order for us to get S1 ln yt, S2 ln yt, and then S3 ln yt. Now if we're able to find all those 3 parts, then we shall be able now to see how we can now get our gompertz curve, our beta naught, beta 1 and beta 2. Now from here members, we shall need to find our S1. Now what's our S1 ln yt? If I add these ones, what's my answer? My answer, I have something like 17.5, yes, 5, 8, 7. Then what is now our S2 ln yt? It's going to be, if I add this second third, I will have 20.558, 20.558. And then lastly, what's our S3 ln yt? It's going to be 21.228, something like this. But remember, as you see that now here I'm saying that what we first need to do, we find the yt, yes. So if I ln yt, now we divide ln yt, the column, into 3 equal parts. S1 y ln yt, S2 ln yt, and then S3 ln yt. This is S3 ln yt. And after getting this value, yes colleagues, now if one not find the beta naught, beta 1 and beta 2 correspondingly, shall need to apply our formulas, but now this time around we're going to have component of ln in them. Therefore, we just need to say that our beta 2 power n is the same thing as having S2, S3 ln yt minus S2 ln YT out of S2 ln YT minus S1 ln YT, something like that. Then we shall just need to have that our beta power 5, the same thing as having 21.228, yes, minus that should be 20.558, something like that. Now divide by 20.558, then minus, then 17.587, and then if I just put this power this side, power 1 over 5, I have my beta 2 as 0.742. Now from there I can find also my beta 1. My beta 1 is my beta 1 lean. Now here I said lean beta 1. The formula is what lean beta 1 equals to now S2 lean YT minus S1 lean YT equal times beta 2 minus 1 over beta 2 power n minus 1 everything squared. Then we substitute here, we shall have our lean beta 1 as now S2, that will be 20.558 minus 17.587, something like this. Then into, I'll have my beta 2 as 0.742 minus 1 over 0.742 squared. Power n is 5, then minus 1 everything squared. Then from here, let's say that my lean beta 1, the same thing as having negative 1.274, and then therefore to have my beta 1, I have my the antilog, so it will be now 0.279, and then I'll be able to have my beta 1, and then likewise I can now find now my beta naught. How do I find my beta naught? By just getting the formula also, but my beta naught is going to be the same as having beta naught. The formula is lean beta naught is the same as having 1 over n into S1 lean T, yes, lean YT, sorry, minus beta 2 power n minus 1 over beta 2 minus 1. The whole of this thing times lean beta 1. And then we shall be able to have our answer now. Therefore, here 1 over n is 1 over 5. This is one lean beta naught. S1 we have it at 17.587, then minus our beta 2 we have it as 0.742 power 5 minus 1 out of 0.742 minus 1. Then lean beta 1 is the same as having negative, so it's a negative 1.274, something like this. And therefore, conclude that our lean beta naught is the same thing as having, if I press the calculator properly, I have 4.283, and then our beta naught is going to be the same as having 72.448, yes, something like this. Now with that, now I can just rewrite my equation as simple as now pressing back my coefficients into that form, and then I'll have my answer as something like simple like this. I'll have my answer as my YT per hat is the same as having beta naught equals to be 72.448 power beta 1, which is my beta 1 was 0.279. Then this beta 1 power now beta 2, which is 0.472, then power t, something like this. And that's going to be my gompertz curve. Members, I think with that, let us call it a day. And then I urge you to read and then also do your calculations and do more examples like this. I think with this, I've tried to show you how we do this. Members, lastly but not the least, I want to thank our colleague who brought us these markers. They are helping us do a wonderful thing, as you are seeing. And members, we need more help like this. Whoever has anything to offer should offer it. And then this friend of ours is contesting for the post of the Cobham's EC, and his name is I'm not sure his post up, you will see it, and then members endeavor to see him and support him. Okay, members, thank you for watching. This is Shaka Anwar, the math tutor, and I remain Shaka Anwar, the math tutor.